Have you ever looked up into the sky and wondered how something as massive as an airplane can stay in the air? A large passenger airplane can weigh more than 400,000 kilograms, yet it glides smoothly thousands of meters above the ground. To many people, it almost feels like magic. A giant metal machine floating through the sky seems impossible if we only think about gravity pulling everything down. But the truth is, airplane flight is not magic at all. It is physics. Behind every takeoff, every smooth landing, and every long flight across the ocean lies a fascinating combination of aerodynamic principles. Engineers and scientists have studied these principles for more than a century to design wings that can generate enough force to lift airplanes into the sky. One of the most important ideas behind flight is something called lift. For an airplane to fly, it must overcome the force of gravity that pulls it downward toward the Earth. Gravity is always acting on the airplane's mass, trying to bring it back to the ground. To stay in the air, the airplane must generate an upward force that is stronger than its weight. This upward force is called lift. Lift is one of the four main forces acting on an aircraft during flight. These four forces are weight, the force of gravity pulling the airplane downward; lift, the upward force that keeps the airplane in the air; thrust, the forward force generated by the engines; drag, the resistance caused by air pushing against the airplane. When an airplane is flying steadily, these forces are balanced. Thrust pushes the airplane forward, air flows over the wings, and the wings create lift that counters the aircraft's weight. But the big question is, how exactly do wings create lift? To answer that question, we need to look at the shape of an airplane wing. Airplane wings are not flat like boards. Instead, they are designed with a very special shape known as an airfoil. If you look at the side profile of a wing, you will notice something interesting. The top surface of the wing is curved, while the bottom surface is flatter. This shape is extremely important because it changes the way air moves around the wing. As an airplane moves forward through the air, air flows around the wing. Some air travels over the top surface, and some air flows underneath the wing. Because the top of the wing is curved, the air traveling over the top must move a longer distance in the same amount of time compared to the air traveling underneath. This difference in airflow speed plays a key role in generating lift. To understand why, we need to introduce a famous principle in fluid dynamics known as the Bernoulli effect. The Bernoulli effect is a principle in physics that explains how pressure changes when the speed of a fluid changes. In simple terms, the Bernoulli principle states, when a fluid moves faster, its pressure decreases. Air behaves like a fluid, just like water flowing in a pipe. This means that when air speeds up, the pressure it exerts becomes lower. This relationship between speed and pressure is the key to understanding how wings create lift. When air flows over and under an airplane wing, the shape of the wing causes the air on top to move faster than the air underneath. Because the air on top moves faster, the pressure there becomes lower. Meanwhile, the air under the wing moves slightly slower, which means the pressure underneath remains higher. This pressure difference is what produces lift. What happens on the wing? Let's imagine the airflow around a wing during flight. As the airplane moves forward, air begins to split at the front edge of the wing. Some air travels above the wing while the rest flows below it. Because of the curved shape of the upper surface, the air flowing over the top speeds up. According to the Bernoulli effect, faster airflow results in lower pressure. Underneath the wing, the air moves slightly slower. Slower airflow produces higher pressure. Now we have a situation where the pressure above the wing is lower, The pressure below the wing is higher. Nature always pushes from high pressure toward low pressure. Because the pressure underneath the wing is higher, it pushes upward on the wing surface. This upward push is what we call lift. As long as the airplane continues moving forward and air keeps flowing over the wings, lift continues to be generated. When the lift force becomes greater than the airplane's weight, the aircraft can rise into the sky. This elegant balance between airflow speed and pressure is one of the most beautiful examples of physics in everyday life. However, wing shape and airflow are not the only factors that affect lift. Pilots also control another important factor known as the angle of attack. The angle of attack refers to the angle between the wing and the direction of the incoming airflow. Imagine holding your hand outside a moving car window. If your hand is flat, the air passes smoothly over it. But if you tilt your hand slightly upward, you will feel the air pushing your hand upward. The same idea applies to airplane wings. When the pilot tilts the wing slightly upward relative to the airflow, the wing deflects more air downward. According to Newton's third law of motion, when the wing pushes air downward, the air pushes the wing upward. This increases the amount of lift generated by the wing. Pilots adjust the angle of attack during takeoff, climbing, cruising, and landing to control how much lift the wings produce. However, there is a limit. If the angle becomes too steep, airflow over the wing can become unstable and separate from the surface. When this happens, lift suddenly decreases. This condition is called a stall. Understanding and controlling the angle of attack is therefore essential for safe and efficient flight. So how do airplanes stay in the sky? The answer lies in the incredible interaction between airflow, pressure, and wing design. The curved shape of the wing causes air to move faster over the top surface and slower underneath. According to the Bernoulli effect, faster air creates lower pressure. This difference in pressure between the top and bottom of the wing generates an upward force called lift. Combined with forward thrusts from the engines and careful control of the angle of attack, this lift allows airplanes to rise into the sky and travel across continents and oceans. The next time you look out of an airplane window or see a jet flying high above, remember that it's not magic keeping it there. It's physics, beautiful, powerful, and constantly at work. And understanding these principles reminds us just how incredible human engineering can be when it is guided by the laws of nature.